Hello, I'm Yinian Zhang. This is my COMP3015 Coursework2. It is developed by my Coursework1, the project in here. In here, we can see the new thing is add a new model umbrella in here, and add some and add the shadow and GR in here, and also add a mouse control in here. You can change your visual angle in here, and others control is similar with the coursework one in here. So first of all, for the shadow, to create the parameter for the shadows, FBO or the deeps texture or the deeps data in here, and turn to CPP. So the first is to create the FBO in here, and it is created new textures and and bending it to the current OpenGL context as a 2D texture in here, and is to define the textures format and size in here, and then is to parameter controller how the textures behaves when the mappers are to geometry, and it's to FBO created and bound. Then the deep textures is treated as the deep components in here, and then it's checked if the FBO is the correctly set up, and if any configuration is the incorrect, so it logs or record the error message in here, and then it's the unbending the FBO and the textures to avoid the accidental modifications, and the last one is to adjust the depends values of the shadow testing to help them minimize the fighting in the for the shader communication is to link and use the shadow, the vertex, the shader, and the shadow fragment shaders in here, the lighting positions of the shadow maps, and the view and the projections of the light source have been set, and then the render shader functions which renders the schedule from the perspective of the light source to generate the shadow maps here. In the rendered shadow, we can see in here, and this is to set the offset, and is the band the frame the buffer object in here, and clip the dips buffers in here, and to set the view plot size in here, and it's to activate the use the shaders programs in here, and to render the schedule, and to restore the default the frame buffer and view plot setting in here, and then is to disable the offset in here. Translate the deep texture data in the render schedule in here, and then just normal render the shade the shadow in here according to the shadow deep texture in the basic uniform vertex shader, and add shadow positions in here, and the shadow positions is seen from the perspective of the light source, and the shadow positions will transfer the data from the vertex shaders to the fragment shader. And it is calculated by the light PV and the freak position in here. And in basic uniform the fragment shaders, we can see these two line code. So the first one is to transforming the to shader texture the coordinate in here, and this one is to simply the shadow map, and the more detail is to they cover the clip space the coordinates and to usable textures coordinates, and then to use these the coordinates to preform the basic shadow texts. And for the PBR, it's about roughness and metallic. And in here, it's about the PBR, the basic lighting model, and this one is the calculate the GGX and distribution in term representing the probably the density functions of the microphase normals the oriented at a specific angle, and this one is the compute the smize shadowing masking function, which accounts for the shadowing and the masking effects due to the macro the faced and orientations. And this one is the calculate the Ferdinand term using the Schoolkey approximation, which models the reflectivity of the surface based on the viewing angle. And final one is the components the difference and the specular contributions of the microphase models to compute the final reflected light intensity, and it will implied or rendered in the schedule basic for the CPV in here. Each model can have these two parameters here. And the final one is the mouse event. It's the function, the process, the mouse position, and it is the effectively used state the variables to keep track of the previous positions, and to try to calculate the movements, the details to update the camera orientation accordingly by the mouse move.